video today is to talk to you a little bit about the ONWA 9-axis sensor. So this is a real sweet sensor that's used for boats. It's made out of a company out of Hong Kong, ONWA Marine. And what's interesting about this sensor is that in a small little package, it gives you the latitude, longitude, so the GPS location, but it also gives you boat attitude. So in other words, it gives you the roll and pitch angles measurements. It also gives you temperature and, most importantly, magnetic heading. So in one simple sensor with the serial communication port, you've got all of these measurements coming back into the boat. All right, so Stephen, if you'll come and kind of look at this screen here, you'll move that camera. I want to show you this screen here real quick. And if you can kind of zoom in on this screen right here. Okay, so this is the information screen, the little software package that is supplied for free with this little sensor, just to show you the sort of measurements that are being made. You can see right now it's showing the heading, the roll and pitch, so attitude of the boat, showing speed based on if you were dragging this along in a boat, it would show you the speed. We're in a metal shop right now, but if we were outside of it, it would show multiple satellites connected. And so basically this is the basic information. Latitude and longitude is displayed. You can see right here the serial communication is through a NEMA 0183 protocol. And so this just shows the strings that are being sent out. All right, so what we're going to do is a kind of a three-part process. The first part is going to be just to kind of walk through how this is wired. As soon as you get it back from the manufacturer, how you wire it. The second step is this sensor is made for boats. In other words, if it rains, it'll protect it, but it's really not made for submersion. So the second part of it is we're going to go through a DIY project on how do you pot this to try to take it to 1,000 feet underwater. And then the third part of the test will be, in a subsequent video, will be to put it in a test chamber and confirm that it can reach those depths and still operate. All right, so when you get the unit from the manufacturer, it just comes basically with a long pigtail here, okay? So to connect it up to a laptop, what we're gonna do is just follow this wiring diagram, right? So in order for, this is a RS-232 communication, in order to talk to a USB port on a laptop, we're going to follow this wiring diagram. So we have to make a conversion from RS-232 to USB. All right, so there's many little modules that do that. The one I'm currently using is here, this wave share USB to RS-232. Here's kind of a picture of it right here. And all it does is take an RS-232 serial communication and send it over to USB so we could plug into a laptop. All right. So also, for power supply, it needs to be 5 volts here. So I'm simply running through a small DC converter here to convert from 12 volts to 5 volts regulated voltage here. So that's the power supply. And you can see the pinout over here. This is just a normal RS-232. Just have a small little connector to allow you to plug into your laptop here. Okay. All right. So what we're going to do is we're going to use this West Marine 105 resin, is epoxy resin, and the West Systems 209 hardener. This is an extra slow hardening catalyst. So with this, it'll give us about 40 to 50 minutes of time before the epoxy starts to set up, and a full 24 hours for it to be completely cured. All right, so the first thing we're going to do is we've got a procedure that I've kind of worked up that we're going to kind of go through in doing this potting process. So our goal is to get this container here, totally full of epoxy. And so anyway, so first things first, we'll go ahead and take this apart. So when it comes from the manufacturer, we can basically just rotate this. You might have to use a pair of pliers, but it's not awfully tight. So we're going to take this apart. So you can see, Stephen, if you'll zoom in on here, we see it's got an O-ring seal. Of course, that won't be necessary in the final assembly. We'll use it, but it won't be for water, stopping water, because this will all be filled with epoxy. Here's the PCP on the top. Again, this is a model KA-GC9A. So when I first got this, there at locations on each of these support tabs, there was some like white silicone, and so I took a pick and basically cleaned those off. So first thing we have to do is take this PCP out of the case. All right, so we can do that just getting a little small screwdriver and kind of walking it way around. And so we see here's the PCB. I'm going to disconnect it. So there's 5 leads coming into this PCP right here. Right. So here's the antenna, and those are our connectors here. So what we're going to do is try to fill up this space here with epoxy. Have epoxy completely surrounding this PCB. All right, so what we're going to do is we're going to go to remove the fasteners here. So I'm going to take off this little clip here, and I'm going to take off this backing for the seal that comes with the unit here. Okay. So let me disconnect this. All right, so you can see here, let me take these screws out. You can see this is just a flexible plug that's forced into this recession right here. Of course, this is good for on the surface, but it's not adequate for underwater. So what we're going to do is end up removing this part here, and we'll use this part to hold it centralized, but we're going to have epoxy completely filling this cavity here. Now, the other thing, the reason we have to, one of the modifications that we have to make in order to make this watertight is we're going to put a water block on the conductors. So the issue is this conductor cord is the sheathing is quite flexible. So under pressure, if we just epoxied around here under pressure, that water could migrate between the epoxy and this flexible insulator. So to mitigate that, what we're going to do is strip off we're going to cut the wire at about a location about 3/4 or maybe 5/8 of an inch from this location here, and we'll cut it down here someplace and install about a 1 inch for each of the conductors, 1 inch of bare copper wire, and then just separate those physically when we pot it. That way there's no soft insulator to crush down under pressure, and so hopefully this water block will prevent any water from migrating past this water block. All right, so what we're going to need to do in order to fill this up, we're going to fill from the opposite direction of here. This will be upside down, so we need a fill hole. So I'm going to get a starting place. We're going to drill a 3/8 inch hole through this base in order for the epoxy to be able to flood in. So what I'm going to do is drill a 3/8 hole through this base. All right. So this will allow me to then fill. All right, so what I'm going to do is cut this conductor at about 6 inches from the end so that we could splice in this water block. So I'm going to take about 6 inches, just need to be exact, so approximately 6 inches here, and I'm going to cut this wire at this location here. So what I'm going to do, I've cut the shielding off and insulation off. I've cut it back to it's about a little over like 3 3/4 inches. All right, next thing I'm going to do is strip these wires and put in the small sections of soldered wire, about and maybe 1 inch across these little metal legs of resistors here, so the wire is easy to solder. So now I've got the 5 conductors and plus this shield wire connected up. Okay, I'm going to secure with just a little bit of glue, this UV glue. I'm going to secure that little wire conductor to the base here. Okay. All right, so now all I'm trying to do is separate all these wires. So this is all going to be cast in epoxy. If you see right here this little ledge, this is where the base of the PCB rises here. So there's plenty of separation between these wires and the bottom of the PCB. So at this point, the key thing is just to make sure white is to white, green is to green, etc. And there's nothing is touching anything. Okay, so this is only temporary until the epoxy floods around it, and it'll be totally cast in this location. Actually, I've already done it for here. But I'm just going to rough up the inside of this plastic, ABS plastic, it's a little emery cloth, just to make a rough surface for the epoxy to land on, to be able to adhere to. And we'll blow all this out with a gun. All right, I think we're ready to start preparing the resin. So we'll make sure you wear latex gloves. So what we're going to do next on this procedure is mix up a 3-to-1 by volume of part A and part B. And once we get that, it'll give us about 8 ounces of this catalyzed resin. Right? So then what we're going to do is we're going to put it in this little homemade vacuum chamber, which is just a pressure cooker where I hooked up to my vacuum pump. And we're going to run that on a vacuum for a little while to try to get any bubbles out of here. And what we're going to do is use our syringe, 10 milliliter general purpose syringe, and inject it, turn this assembly, fill this cap first, put it together, and then assemble from the back end. Make up about 8 ounces of this catalyzed resin. So we need about, to make that, we need 6 ounces of part A and 2 ounces B. I've got a 10 milliliter syringe here. So it correlates to about 177.4 of A, 59.1 of B. So this is A right now. So I'm going to take 17 and 3/4 of these. Okay. Okay, so that's one. That's 17.7 milliliters. 17.7 times 10 milliliters. So 177.4 milliliters of A. Now we need to do B. I'm going to get the Hartner. Okay, our Hartner here. I'm just going to pour some in this cup just so I can get at it easier with my syringe. Okay. All right, so I need 5.91 of these. Okay, that's part B. Okay, so the A and B mixed here, about 8 ounces. I'm going to stir it up. You're supposed to stir it for about a minute. So I'm going to stir this up. You can see, and now we've mixed this up for about a minute. I don't know if you can see inside of here, but there's quite a bit of air bubbles entrained into this mixture. So we're going to put it in a vacuum chamber and try to pull some of the air out. I'm going to turn the vacuum pump for a while. Run on vacuum for about a few minutes. We're going to pull some of this air out. The clock is started now. The temperature right now is about 97 degrees Fahrenheit. So probably at 70 degrees, the pot life of this two-part epoxy is about 40 to 50 minutes. So my guess is at 100 degrees, it's more like 30 minutes. So we're definitely on the clock to get this poured in. Okay, it's been about 2 minutes on the vacuum. I'm going to turn the vacuum pump off and let the pressure drop back off of this thing. And hopefully most of that air has been driven off that epoxy. Okay, it's down to 15 inches of mercury. Okay, 10 inches of mercury. Okay, 5 inches of mercury. Okay, we should be getting close to being able to open this. Okay. All right, that worked pretty good. You can see most of this. Let me find me another little small stick. Most of the big bubbles out. There's just a little bit of bubbles on the top here. All right, so I think I'm going to put this under vacuum just a little bit more. Okay, there's a little bit of foam on top. Most of the big bubbles are out, but there's still a few bubbles here. I'm going to put this a little bit more under vacuum. We're doing it by mixing straw. Okay, that second vacuum did it. Now I can see there's a little foam on the top, but basically I can see all the way to the bottom, so it's clear. Just a little bit of foam on top, so that syringe will go to the bottom. So I'll be pulling clear liquid at this point. Okay. All right, that's good enough. It's kind of hard to tell because we still have a little bit of that foam on top, but if you look through that bottom, that little hole, you can see all the way to the bottom. So we know we got the bubbles out of the base of it. Okay, so now we're going to start the injection. Take a little of this catalyzed resin here, and I'm going to apply this to the to the bottom of this PCB. Okay, just to make it easier to make sure it gets all coated. Okay, that way when we start to apply it, it should make it a little easier to coat. Okay, I'm going to flip this over, making sure I'm pointing in the right direction. Okay, so north is this direction. Okay, I'm still looking, all the wires are separated. Okay, so I'm going to push that in. Okay, so now I'm going to put a little bit of this EV glue right on a few of these posts just to support it. And I'm going to put just a drop of this glue at these tabs. All right, and then I'm going to activate it. All right. So now we're going to go ahead and feel the top here. If you'll notice here, we're going to fill the top first. See this little ridge right here? This little ridge here basically comes down on top of this PCB to hold it in place. So we want to make sure we want to fill over the top of that. So basically to the bottom of these threaded section is where we're going to fill to. Okay, so it's all covered to the base of there. Still a few bubbles in there, but when we put it on the vacuum again, we'll get it clear. Okay, so I'm going to rotate this upside down. We'll assemble this. All right. Okay, so now I'm going to go ahead and finish filling this. Okay. All right. So I come in and just feel this. I can always feel this catalyzed resin is getting hot. Okay. I'm going to bring up this level. I'll show you in a minute to the. Okay, I don't know if you can get your. Can you bring that camera over and see if you can see inside of here? A little hard to see here, but I'm trying to bring that level up just to show you. Here's a fill hole. I'm going to try to bring this level up to this level here. Okay, still got a little going in. All right. I'm going to turn this around a little bit just to try to get it all worked into the crevices. Get a little less air out of here. Now I'm going to put this back in the vacuum and see if I can get a little more air out. The thing is definitely getting hot. Yep, but it's clear. You can see it clear. So it looks to me like it's full. If I press the case, I can see the level going up and down. So I'm going to put it back in the vacuum just to see if I can pull out any more air into this vacuum, out of this unit. Okay. I'll put in the unit back together here. Turn the vacuum pump back on. 6 minutes. And since we mixed them with this temperature, it's already potted. It's already started to solidify very hot. If I look in the base of here, if you can look in here even, but if you look down here, you can see that it's clear. Bottom is fairly clear, and it's starting to solidify in here. The unit is definitely a little warm. Okay. All right, that's all. 3 minutes since we potted it. I mean, this thing is already solidified in the cup. The resonance looks like it's solidified. It's starting to solidify here. All right, so all I'm going to do now is wait 24 hours for this to cure, and then we'll test the unit, make sure it's still working, and then move on to the underwater testing. All right, it's about 1 hour and 40 minutes since we potted it. The unit seemed to be working fine. You could tell the temperature is pretty hot, 66 degrees Celsius, so like 150, 160 degrees Fahrenheit. So it's still cooling down from the potting process, but you can see it's functioning. You get latitude and longitude looks correct. You can see the magnetic heading is right now we're outside, kind of rotating it around a little bit, and so we're getting roll and pitch measurements, and so it looks good. So now I just got to wait till it fully cures. But so far, okay. So good. Basically, we're finished casting. You can see the epoxy is set up in the bottom over here, and so the unit seems to be working. Put this inside of the pressure chamber here, and we're going to fill this pressure chamber up with water. We use a pressure washer or high pressure pump to be able to pressurize up to about 2,500 psi. For this test, though, we're going to limit ourselves to about 500 psi, which equates to a little over 1,100 feet seawater. So what we have over here is the pressure chamber, right? And then this is the supply side from the pressure washer. We have an Automation Direct 260 CPU, 205 series PLC, and we're going to data log here. Okay, so we're going to show pressure and temperature in the test chamber, and our our measure of whether this is successful is whether we continue to transmit NEMA sentences. So like right now, this unit is on and it's transmitting. All right? All right, it's been 1 hour. We're still at 940 psi, so it's around 1200 pp. We're still transmitting, and so everything looks good. I'm getting ready to turn off the pressure washer, and pressure in the chamber will start to drop. All right, you see the see the pressure is dropping. We're still transmitting NEMA signals, 0183 sentences. So it's a success. So the bottom line is this ONWA combination GPS compass sensor is customized by potting it with epoxy. Will handle the depth of a small submersible quite easily. All right, next step is to write up a report.